I have this monitor here. This is an HP monitor, and the problem with this is that it doesn't turn on. So I'm going to try to plug this in. There is no display at all. It's supposed to show, there's an LED here that is supposed to, LED indicator here that is supposed to turn on to show that the monitor is on. But now nothing happens anymore. So I'm going to open this up and fix the issue. So first thing we want to do is to ensure that the monitor is disconnected, and we'll flip this backward, remove all the screws at the back. Have 4 screws here, but your own brand and model of monitor might be a bit different from this, so the screw placement might be a bit different. It doesn't matter. So just what you're trying to do is just to remove, take it apart and see the power board inside, the power supply board inside. I want to see what is wrong with it, if it's still fine. So we check the power supply board inside to see if it's still functioning. So we have another screw here. So after that, we're going to remove this stand. And to remove this, now this is opened. So what we want to do is to check the power supply and see what is wrong with the power supply, if power is actually going into the power supply area. This is going to be the power supply area. So I'm going to detach any cable attached to the power supply area. So this is the power supply area. Now, you have to be very careful when you get to this particular part of the power supply area because of the high voltage capacitor inside. There's a high voltage capacitor that is around 400 volts, which is quite high. So you have to be very careful. What you want to do is that you do not touch any of the parts here because you don't know which of the capacitor is high voltage here. So avoid all of this area, avoid touching any part within this area. It is very, very risky because of that high voltage capacitor. So I will avoid touching all of this. I have a safety glove on, but that is not enough. Be very careful when touching all this area. So what I'm going to do is to remove the 4 screws holding this down. supply. So we have no. So this is the power supply board. This is the area we're going to be working on. The first thing we want to do is to do physical examination. We are going to check all of the components on this board and check for physical damage. This is the main cap here. This capacitor here is around 450 volts, 47 UF. From the physical look, it appears to be okay. It is not swollen. There's no bulging parts here. Normally, if the capacitor is bad, you will notice that this part will be bulging, will bulge out. So there's nothing of sort here. So there is nothing of sorts here. Everything here appears to be fine, but I'm not going to just see everything as being fine. So this is how it works. The power supply is going to come from here, and this is the power supply area. It's going to come from this area. So power comes in from this area, which is the primary area, and then power will leave here as this secondary area. After the power has been converted, then it will go into this area as the secondary area. So from here on, they're all the primary area. This is the part that does all the conversion. Then from here we have the transformer here, the work of this transformer. So this transformer here is linking the primary area, which is the part where you connect a 200 volt or 220 volt or the primary voltage to, and then it's going to link it to the secondary area after a lot of conversion has taken place. And then finally, this is the output from this, and it's going to supply the logic board that controls the screen and everything that you can see on your monitor. So I'm going to check the primary side and check all the components, ensure that everything here is fine. Then if everything is fine on the primary side, then I'll move over to the secondary side. What I'm going to be needing here is I'm getting my multimeter. Alright, so I have my multimeter, and then I have my microscope here I'll use to check for all those tiny parts here. So let's see what we have here. So power coming through here, there has to be a fuse here, the components that act like a fuse. So let's check out for any components that act like a fuse here. I'm going to take this to continuity, set it to continuity. And we'll check if there's continuity in the fuse area. Now test for continuity in the fuse. This component here is serving the purpose of a fuse. This is 2.5 amp, 250 volts here. This is still good, and this ceramic capacitor here is still good. I've checked them. These are still fine. So let's see this. So basically the problem with this is this fuse right here. That is a fuse right here. When power came in through this area, either because the power was fluctuating or the power is higher than 250 volts, 2.5 amp. So what is going to happen is that it's going to blow up this fuse right here, and once it blows up this fuse right here, the power won't be able to pass from here into the other components to be able to power your device. So you can see this separation here. There's an opening here. If you look closely, there's an opening here. So when power comes in through here, this is supposed to link this to here. It's supposed to link this from this end to this end. So power is going to come in through this area, and then this fuse here will regulate the power, ensure that the power is not above the rating. The rating here is supposed to be 250 volts, 2.5 amp. Once the power is more than 250 volts, 2.5 amp, this is going to blow up this fuse so that it can protect the other components on your device. It is easier to change a fuse than to change this board completely. You can see at the back here, if you look closely at the back, you will notice an opening here. See, there's an opening here, L-shaped opening. So what happened is that power is supposed to come in through here, and then the power will come into this end. So the power is supposed to be transferred over to this other leg here. But the problem is that from here to here is a fuse. So when power comes in through this end here, positive end of the power comes in through this end here. So for the power to move from this end and jump over to this end, it has to be within 250 volts, 2.5 amp. Once the power is above 250 volts, what happens is that this particular fuse here, this is it, this is the fuse here, is going to blow up so as to protect the other component on your mother, on the power supply board. And that is the problem we are having right now. This has blown up and power is not able to reach the other component of the power supply board so that it can power your device. So what I'm going to do right now is to replace this with the exact same fuse. So let's remove this. Alright, so this is done. This has been replaced with another one. So we are going to couple this back and see if this works. So this is fine now. Everything is working the way it ought to. So the problem with this is the power supply. Thank you for watching. I'll see you in the next one.